Good evening. I'm Katunja Brendan. We are group 22. We are doing graph-based registration and supervised East Coast fever detection. We are going to start with the problem statement. Cattle farmers in Uganda face the challenge of identifying potential outbreaks of East Coast fever early enough for their cattle, as it is very essential in the management and control. So, providing the machine learning model for early detection is very essential, as it is able to recommend farmers to reduce the associated risks of high mortality and reduce profits. The project objectives is that to develop the model for accurate early East Coast fever detection, and also to develop an cost-effective model that reduces reliance on expensive laboratory tests. Also, to provide the enhanced rapid diagnosis, which provides results in minutes instead of days, and also to provide a scalable model that can be deployed in remote areas via mobile apps or web applications. And then lastly, to enhance disease tracking through monitoring of mapping disease spread as we use geographical data. The solution overview is that we start by data processing, and then we construct graphs using the nearest neighbors. We do model optimization using registration. We also deploy using render and simulate. So the dataset used was from Dryad Open Data Publishing Platform. It had some missing values, alphabetic values, and unbalanced ESF class. The rows with missing values were discarded, and also encoding was performed for the alphabetic values to achieve the valid dataset. This is how we came up with the balanced ECF. And the model techniques, we used graph networks, used registration and supervised learning, and graph attention networks. These are the metrics, the accuracy, precision, and F1 scores. This is the system architecture. The data set that was used, we did the processing, we trained the models, came up with the knowledge registration model, and also prediction and deployment on render. The implementation details, the language used during implementation is basically Python. A number of libraries used, including the Torch, NumPy, Pandas, Matlib, sklearn, not mentioned by Tasmin. These are some of the results we obtained, the teacher and student models. Let me invite my colleague, start from here.
Good evening. My name is Bainam Shadrack, and I'm here to continue from where my colleague has stopped. So, our solution aligns with the following SDGs: the SDG 2, which improves food security and economic stability for farmers, and SDG 3, which promotes animal health and indirectly promotes human health, and then SDG 9, which encourages use of AI and machine learning in fields like animal farming. And our target users include veterinary clinics, livestock farmers, animal health workers, and government disease control agencies. And for the intellectual property and innovation, we have the graph-based registration algorithm, the data processing framework, and the diagnostic decision system. And our idea is very copyrightable and protectable in the following ways. The first one, it is copyrightable in that the software implementation can be copyrighted to prevent unauthorized replication, and there's a potential of a trade secret. And then for the monetization and scaling, our solution can be commercialized through subscription model, where you can pay monthly or yearly, then government and NGO partnerships, and pay-per-use API. And for the potential market size, Uganda has over 14 million cattle, and if you include East African countries like Kenya, Tanzania, and Rwanda, where cattle farming is a major economic activity, our market size is estimated to be over 50 million US dollars in East Africa alone. And for the system demonstration, this is basically the user interface, how it looks like, and these are the team contributions per member. As per me, my name is Banam Shaderick, and my colleague is Katunja Brendan. And for the lessons learned for the teamwork challenges, we had a problem of workload balancing, where we couldn't handle. We had an issue of handling technical and business research, and for time, and we also had a challenge of time management and deadlines, where we had different assignments always coming in at the same time. And for the technical challenges, we had the problem of unsupervised and supervised learning complexity, and then feature extraction complexity and integration with the cloud, where deploying the model effectively with the cloud was difficult, since some cloud platforms had limited resources which could accommodate our machine learning models. And for the lessons learned, we learned that optimization is key, data processing is very important, and collaboration is critical. And for the future work, we plan on expanding the data sources, also planning on deploying our machine learning model on low power IoT devices so that farmers can easily use them to diagnose diseases. And we also plan to extend our 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 solution from just local to regional and global expansion and integration with veterinary systems. And in conclusion, our achievements is one of a few of them which I can mention is that we developed a hybrid machine learning model and we integrated graph neural networks and supervised learning and registration and all those concepts of machine learning. And then we also created a lightweight model using registration. And the value of our solution is that it provides timely and actionable information to farmers, and it also provides timely and actionable information to farmers, and that's the impacts. So that's it from us. Thank you very much.